this video, we're going to be discussing how do we write an equation of a line that best represents that linear function. Okay, so in this video specifically, we're going to be talking about the best one to use, and sometimes there might be two different forms we can write. So let's first talk about the three types of equations that I can write that represent a line. So the first type of way I can write a line is in slope-intercept form, and this basically means that I have a slope, which in this case here would be my m, and I have my b, which is my y-intercept. And that was a little spotty, so let me just go ahead and fix that. So y-int, let's go ahead and just put int dot. Okay, so now for point slope is basically in its name, we have a point and we have a slope. So our point here is y1 and x1, and we're subtracting that from our x's, so this is my point. And then here, right here, I have my slope again, which we still call m to keep consistent. Now, in standard form, I don't really have any of my attributes. I don't have a y-intercept, I don't have a slope in the equation, but what's basically happening here is I have what I'm multiplying x by, what I'm multiplying by y by, and the very key thing here is that I have a total. I also have three I have three numbers here, or three coefficients here that, usually in a real world situation, it would be very apparent. I don't have just a slope and a y-intercept, I have three numbers, and we'll see that in one of our examples. But the main thing here is that I have a total value, or a total number. Okay, so here I have Mrs. Andrews' dryer broke, and she has to call a mechanic to fix it. The mechanic charges a flat fee. I would go ahead and highlight that, a flat fee of $20 and $5 for each hour to fix it. So the flat fee here only happens once, and it's our starting value. So this right here would be our y-intercept. The $5 each hour is clearly our rate of change, so it is our slope. So here, the best equation I can write here, since I have a slope and a y-intercept, is in slope-intercept form. So let's go back to my equations here. I would write it in y equals mx plus b. So what I would write is y equals 5x plus 20. So again, the best way to write this and explain what's happening is this way: $5 per each hour. Remember, x here would mean each hour. Y is giving me my cost here. Okay, so in this next piece right here, I have that the Student Council is hosting a bake sale to raise money for a charity. They sell brownies at $2 a piece, and they sell cookies at 50 cents a piece. Their total is $15. So we're going to go ahead and say that number of brownies is x, since they did not define that for us, and that the number of cookies is y. Okay, so here they're telling us that the total here is $15. So if we go back here, remember, if I have a total with my number here, that's standard form, and so they're telling me what I'm multiplying x by. So $2 for x, so 2 times x, plus 50 cents times y equals a total of $15. So this one was a nice standard form equation. All right, now in this case right here, I have that the slope of the line is 2. So I have the slope, and I have a point, an x1 and a y1. So the best equation that I can use here is my point slope. And this might be newer for a lot of people, so I'm going to go ahead and write what that equation looks like. So it's y minus y1 equals m parentheses x minus x1. And you will always have this in your reference sheet to kind of like look back at it. So I'm going to go ahead and plug in my point. So y minus my y1, which is 3, is equal to 2 parentheses x minus my x1, which is 2. And that's it. This is the equation that can best represent the situation. Now here I have 2 points. Well, definitely have an x1 and a y1. Now, so I'm leaning more towards using a point slope, but how can I go ahead and find the slope? Well, how do you find the slope between 2 points, the rate of change? Well, you use the slope formula. So first we need to find our m by using our slope formula to see how far, like what is the rate of change between these points. So I would do 1 minus negative 3, which is 1 plus 3, over 4 minus negative 4, which is 4 plus 4. So again, we're using our slope formula, which is y2 minus y1 over x2 minus x1. And so here I would have 4, and down here I would have 8. And so this simplifies to 1/2. So my slope here is 1/2. And in this case, I only need 1 point for point slope. So I can pick one or the other. I think this one just looks a little bit more attractive to me because it doesn't have negatives. So we're going to use that one for point slope. So remember, our point slope has y minus the y value of my point. So y minus 1 is equal to 1/2 parentheses x minus 4. And so the most common error that I see is that people want to mix in both of these equations, both of these points into my point slope. You only need 1 point here. I took care of the other point by making sure that I have a slope of 1/2, which is going to make sure that it hits this point as well. All right, so now let's go ahead and look at this situation. Here I have a table. Now in this situation, this is what I was getting, that we might have 2 ways to get it. Let's first, obviously, the first thing we want to identify is the slope here. So the change in y here is plus 3. The change in x is plus 1. So my slope here is 3. So right now I have a slope, so I can use slope-intercept or point slope. Obviously, I also have a point, so I might want to go ahead and do point slope. So if I use point slope, I'm going to do y minus the y value is equal to the slope times x minus the x value. So that's one way that I could have done it. The other way I could have gotten an equation to this line is, well, I have the slope, I can figure out what the y-intercept is. Well, I have a table here, so I know what the pattern is. I'm trying to find the value of y when x is 0, so I can go backwards to 2, and then 1, and then 0. Right? And I know what the pattern is. Well, my y's are going backwards by 3. So obviously my x's were going backwards, we're going up by 1, so I'm going backwards by 1, right? So that was easy, but this I would have to keep subtracting 3 and go backwards that way. So 7 minus 3 would be 4. 4 minus 3 would be 1. And 1 minus 3 would be negative 2. So there you go, I got my y-intercept. My y-intercept is negative 2. And so I can also write that the equation of this line is y equals to 3x minus 2. And in the next lesson, what we're going to be talking about is how do I convert this into this? Well, yes, I could go ahead and distribute, and 3 times 3 is negative 9, and add a 7, and there you go, you would get your y-intercept. So we are going to talk about that in the next lesson. Okay, now if we have a graph here, well, let's see, what information do I have on this graph? Well, I do have the y-intercept, great. And I can figure out the slope. The slope is a rise or a run. Okay, so let me go ahead and take that out of the way. I can go down 1 over 3. So my slope is negative 1 over 3. My y-intercept is 2. So I can write that the equation of this line is y equals to negative 3x plus 2. I can also definitely write this in a point slope, right? I have a point right here, which is 3, 1. And I can write y minus 1 is equal to the slope, which is negative 1/3 x minus 3. And this is the same exact line. And again, in the next lesson, we're going to show how we're going to convert that to show that. So those are 2 ways we could write the same line. And then now these are sort of our special cases. We talked about that this here, my slope of this line, right, is 0. So I know what the slope is on here. And my y-intercept here is negative 1. So I'm going to go ahead and write y equals negative 1x. Not negative 1x, sorry. My slope, which is 0x minus 1. And so here, this 0x is kind of redundant. I know that number is 0 no matter whenever I multiply anything by by 0, 0, so we can get rid of that and just write y equals -1. Now this line right here is actually not even a function. I cannot use any of the 3 methods that I talked about to actually write this. The only thing that I can describe of what's happening, well, what's happening here is that my x is always 3. So the only thing I can say is x equals 3. If I try to use slope in point slope or slope-intercept, well, think about it. My slope is undefined. I don't know what it is. That's like writing the answer is I don't know. That doesn't tell me much. I want an equation that describes this. My y-intercept is also, it doesn't touch the y axis, is also undefined, and that doesn't give me much. So the only thing I can say is that x is equal to 3. Again, because it's not a function, so this one's like the oddball out there. So a way to kind of remember this is that a y equals equation crosses through the y-axis and an x equals equation crosses through the x-axis. So I hope that you found this video very helpful in how to determine what is the best equation that you can write for any specific line.